Well, good afternoon, everyone. Welcome to the Hamsai Telecon. I think we don't have any particular agenda this week, so I think we will run it in the Tapper Tangerine SDR style, which is where we go through and everyone can make a couple comments, and then they can, let us know if they have anything they want to present. And after that, we can just have general discussion. So why don't we start? I'll go through the list as I see in the order of pictures on here. So why don't we start with Bob? How are you, Bob?
On mute?
Are you muted, Bob?
I think so.
Yeah. You can't unmute yourself.
There you go.
There you go.
Can you hear me now?
Yes.
Good afternoon, everyone. This is Bob. Call sign WK2Y. Just been playing with VOA Cap and going through a bunch of different, just tweaking the knobs, I guess, as Nathaniel would say, and seeing what the different outputs give me and seeing what the sensitivity of the propagation model is to variations in its inputs, and also discovering that never assume that things are more complex than they need be, right, Nathaniel?
That's right, exactly. Very simple.
I wanted to figure out how the signal to noise ratio was calculated, and got involved in trying to calculate some logarithms and things like that. It turns out that they subtract the received and the noise, and that's how they get the signal to noise ratio. Simple subtraction. Duh. Anyway, carry on.
Thank you very much, Bob. Dave, KD0EAG, go ahead.
I'm sorry, I didn't. Was
Go
that
ahead.
me?
Yeah. That's you.
Oh, hi. I've been just working on magnetometer test code and trying to keep up with the foolishnesses that I've put in that Julius Maddie keeps finding for me with his old Tektronix setup of some sort. But other than that, I'm just plugging away.
That sounds very good. Thank you very much. Yeah, I don't think I've ever actually met Julius before, but he's been quite helpful so far.
Oh yes, very helpful. And especially once he got, kind of understood exactly what we were trying to do. At first there was some confusion, but he's been extremely helpful to me.
Yeah, it's neat too. I have to talk with him, but it looks like he was very involved with the U.S. Antarctic program back when it first started in 1957. And if you Google his call sign, you'll find that he was one of the people that ran most of the phone patches for the Antarctic people back then.
Oh, really? Wow.
Yeah, it's really neat. So I need to talk with him more. I think I can put that link in the, there's a link in the chat you can see.
I see he got his first license. I don't know much about him, but I see he got his initial license in the year I was born, and that's getting to be a long time ago now, 1954. So.
Yeah, take a look at that link. All right, Mike, AA8K.
Greetings to everyone. I enjoyed the discussion on the loop antennas on Monday. That's a much preferred solution for me. Eager to find out more about that.
Yeah, thank you very much, Mike. I hope that will turn out to be a good solution. We'll have to work on that some more. All right, David Kasdan, AD8Y.
Greetings all. I'm not sure I have too much to
add to comments right now. I'm afraid I came in a few minutes late. I don't know what the discussion is.
Oh, we're just taking general comments about what people have been doing this past 2 weeks.
I'm slightly embarrassed to say that my great electronics triumph for the week was getting a broadcast band AM transmitter working, a one vacuum tube arrangement. So nothing very pertinent. Greetings all.
Very good. Carl, K9LA.
Hey, how you doing, Nathaniel, and everyone else? Dave W. mentioned 54 a long time ago. Oh, that's nothing really. I bet you Bill NQ6Z would agree with me, wouldn't you? Been having fun working on a project, and which has nothing to do with the HamSCI, but I thought I'd check in and just make sure I keep abreast of what's going on, because it's very interesting what happens on these videos. So that's it.
Thank you very much. All right. Let's see. Tom McDermott, I see you have a antenna behind you.
Yeah, this is the antenna that we were talking about on Monday. Let me see if I can get it closer to the camera.
Looks nice and weatherproof.
Yeah,
It's inside the box.
Yeah, it's very low cost. The box is a Home Depot electrical box. It's 2 pieces of 10-foot PEX tubing, a couple of fittings, and inside each PEX tubing is a 10-foot length of RG8X. The shield's been broken in the center. And then inside the box is some perf board and a couple of home-brewed bipolar differential amplifiers with some common mode rejection and some AC broadcast band traps. And each amplifier is powered through the coax. So there's a couple of type F fittings on the box. And so there's 2 antennas and they're perpendicular to each other. And so that's the antenna that I was referring to on Monday.
That looks really good, Tom. Thank you.
Is that for HF only, or?
It goes from about 350 kilohertz up to about 20 to 25 megahertz. It's broadband, no tuning.
Ooh, very nice.
Yeah, so I was saying that I think something like that would be a good solution for the personal space weather station, especially the tangerine-based one where we want to have cross polarization antennas. We want the broadband receive performance. We want low cost, and we want a modest footprint so that it's not too hard for someone to put in their backyard.
I'm wondering, could you use that as a receive antenna and have the loops switchable, or would that, and so that you would have some directionality on the reception?
Right now, it's intended that you run both loops at the same time, one into each of 2 different matched phase coherent receivers. And then if you do that, of course, you can extract all the different polarization states from the antenna.
So basically what you're doing is you're just pulling, you're looking at the I and Q independently from that?
Yeah. So if you think of one antenna as V and the other as H, which is not correct, but that's the terminology folks use. So the one receiver extracts I and Q from the V antenna. The other receiver extracts I and Q from the H antenna. And with those 4 components, you can basically undo any modulation and polarization scheme.
Right. Yeah, that makes sense.
Yeah. Thank you. Jerry, why don't you go ahead?
I don't have anything really interesting to report about. The only thing I've done successful was get a long wire up in the last couple of weeks, and then I haven't had a chance to run coax to it.
Hopefully that will come soon.
But this telework thing has proved to be harder than I had expected.
Mm-hmm.
So
Yeah, it's actually very time consuming.
That they can get a hold of me a lot easier. So I'm finding myself working too many hours.
Mm-hmm.
When they actually had to gird their loins and walk into my office to ask for something, it was a lot easier.
Yeah.
Now they can just drop something on Slack and demand that it get done right now.
And everyone can do that.
Way too many people are doing it.
Yeah.
But yeah, I've got a long wire and a couple of VHF antennas up. Got the USRP1 powered back up, but I've got to get an antenna going for it to start looking at the lightning spectrum again. And I really need to find a way to get a good low price Ethernet connected SDR so that I can do that and get better bandwidth and start playing. But right now, that's not in the budget to go out and get one of the 200 or 300 series from National Instruments.
Mm-hmm. Yeah, sounds good. All right. Let's see. So, Bill, NQ6Z, how are you today?
I'm doing fine, except I have a Wi-Fi problem at my house and I haven't figured out what it is yet. So until I get that solved, I'm not really hearing anybody. Like 20 meters from Europe is dead in Virginia right now at my place.
That's unfortunate. Did that just start?
Yep. So something happened in the neighborhood and I got to just figure it out.
All right. Well, good luck with that.
Yep.
David McGaw.
Can you hear me okay?
Yep.
Okay. Got a bunch of stuff going on over here in spite of Dartmouth's shutdown. Actually, they're talking about reopening some of our activities, though I'm allowed back in the lab when I need to anyway. But I think primarily right now I'm working on antennas, trying to set up a cross loop for VLF. And then I've got a test site for our AM Doppler system. Our AM Doppler's experiment is fully deployed right now. We have 6 receivers out around the Northeast from New Jersey and Cornell, Messina, Dartmouth, UMass Dartmouth by coincidence, and Schenectady in the center. And getting good data out of that, trying to see if we can pick up some gravity waves in the AM region. And then looking at one of our latest projects is we use much larger loops than Tom is using, but at a little bit lower frequency. We have a lot of 10-foot on a side loops that we use from 100 kilohertz up to 5 megahertz. And we're hoping to deploy something up on Baffin Island, which is conjugate to South Pole, and watch signals bounce back and forth between the two. We can't get up there, and our alternate crew, who we were hoping to put stuff in, can't get up there due to the current situation. So we have to come up with a field deployable system, which I'm thinking of as akin to pitching a tent. But we're going to work on that, see if we can figure out something that, if somebody just knows how to pitch a tent, they can set up our antenna and receiver system for us.
That sounds like a lot going on. Sorry about the Baffin Island issues. I wonder, once we get the HF Doppler setup run more, I wonder if we'll be able to see similar TIDs as as your AM system does. It'd be interesting to compare those observations.
Yes, indeed. Yeah, one of the questions actually that might be for the greater Hamsai community is our system that we'll be putting up there. It'll be running USRP, dual channel. We're actually not using crossed loops, but loops separated by 50 meters or so to run it as an interferometer. The basic accuracy or stability of the USRP, I understand, is like 2.5 parts per million. We're debating whether to send a GPS disciplined oscillator up there with it. And the question is there science? For our immediate science, we don't need it. But there may be other science that obviously could be done with that system that may want a more accurate frequency reference.
Yeah, that'll be interesting to see. Yeah, because most of the TIDs that you're looking at, they're generally, between like 15 minutes to, an hour or so, right?
What was that?
The TIDs that you're looking at, they're generally like 15 minutes to an hour or so.
Right.
In terms of period, yeah. All right. Well, thank you very much.
Well,
yeah.
Report that on the AM Doppler with our the data we're getting, we're seeing a lot of spread F events, more so than the gravity waves that we're looking for.
Very good. Do you want to explain to people what spread F is?
Well, it's because the ionosphere doesn't act as a perfect reflector. It's actually a bunch of blobs moving at different speeds. You get varying Doppler shifts. And so what normally would be a single frequency carrier coming down gets split and spread. And apparently, I guess there are two primary forms of spread F. There's one that happens at the equator, one that happens up here.
Mid-latitude spread F.
Up this way.
Yeah. All right, thanks. Let's go over to Christina. Christina, KD8OXT. You like to say hi? There you go.
Hey folks, how's it going? Sorry I was on mute there. Let's see. So the whoops, it's the wrong link. The main thing that I would like to let me just toss a link in the chat. Bring up to this group in our weekly Doppler telecons to talk about the low-cost personal space weather station project. We had a discussion of doing the same thing that we did in October for the Festival of Frequency Measurement, but for the annular solar eclipse that's crossing Asia and parts of Africa in a month. And so I am looking for stations to recruit to take Doppler data. We have a nice protocol for people to take data just with FLDigi. And it's the same thing that we did for the WWV Centennial, which we've been working on. Data analysis from that and correlating those has started to get rather interesting. So I don't have enough D expertise to be able to find very many stations that would be well positioned, but the link that I just put in the chat there has all the information, and please shoot me a message if you can think of any stations that would be good to recruit, any mailing lists that it would be good to send out a recruitment call over to get the word out, see if we can use this opportunity to do some data collection. Plus, I just learned that that eclipse will be on Nathaniel's birthday, so there's that.
Thank you very much, Christina. So if anyone has some contacts for her to help her get the word out about this eclipse, please put it in the chat or send her an email. And I guess, Christina, you can put your email in the chat too, right? All right. So next, why don't we hear from Dev? Go ahead.
Hello, everyone. Good afternoon. We have been trying to think towards deciding which ionosonde would be the best to use as the receiver in our projected personal space weather station. So we have been discussing on a few options, DigiSonde, and we're tilting towards chirp INO Sunday. So who continuously transmit the radio waves, and we're in the process of locating them where they are and figuring out how they could be helpful. So that's where we are. Thank you.
Yes, thank you very much, Dev. So yeah, we are trying to figure out a good mode for the Tangerine SDR for making observations. And what we'd like to do is make use of ionosons that already exist and try to make oblique ionograms. And we think the easiest way to go about that is to start off with FM chirp ionosons. So Juha Virinen, who used to work at MIT Haystack Observatory, and he's now up at the University of Tromsø in Norway. He has actually done this sort of thing before and has even released code which will create these oblique ionograms, and this is what he calls the GNU Chirp Sounder project. So Dev is working on that. And we are, if anyone knows of what frequencies and what locations different chirp sounders are located, please let us know. We need to find out where all of these chirp sounders that we can listen to are actually located.
Okay, Nathaniel?
Yes, Bill.
See this, the second paragraph right underneath there, there's a box, like a picture should be there.
Yes.
Click on that box.
Ah.
Okay, so for folks who have been visiting that website and not seen the pictures, yeah, the HTML is bad, but if you just click on the box, the pictures come up.
Oh, that's really good to know. I didn't know that.
Yeah, well, it took me a while to find that too.
Thank you very much. Okay. So let me stop the sharing here for a minute. Me controls. So next, why don't we go to Robinette?
Oh my goodness. Hello, everyone. Sorry I showed up late. Don't really have, I've been extremely busy. We've been working on a database for the Whisper daemon. We are thinking that is looking very promising. We're cloning the WhisperNet database into a full-on SQL database, and we can query in milliseconds, where it takes them 20 or 30 milliseconds. So hopefully this will be useful to others. The timescale database we're using is really a dramatic improvement over the MySQL and other approaches. So if that becomes relevant to the group, we're pretty much done with it at this point. And it's getting wired up. If those of you who use whispernet.org probably know how inefficient it is, and sometimes you can wait for minutes to get your queries responded. So this should address that, and we're creating additional information, noise data that we've talked about before. So that's my area of activity.
Thank you very much, Rob. That sounds great. Diego, go ahead.
Hello, everyone. Everyone's doing well.
We started with you, didn't we?
Yes, although there weren't that many people here yet.
Yeah, that's right. We didn't start with you officially, so go ahead.
Yeah. Currently, I'm working on some 2D line plots using WhisperNet and RBN data. I hit kind of a hitch just because my current knowledge in Python, but that's what I'm currently working on.
Right, you are working to extract the TIDs from the RBN and Whisper data.
Yes.
Great. Okay, working. Thank you very much, Diego. Let's see here. Who have we? John, N8OBJ, have we heard from you yet?
Not yet.
Great.
I went through all the documents you emailed me last time concerning the file structure and everything, and have incorporated that into the new document. I've changed the format of some things to accommodate the broader scope of the whole project. I'm incorporating that in my next release of my low-cost personal space weather stations that I'm going to deploy, one in Pennsylvania to Aden and another one to a friend in Auburn, as well as my two and David's and Christina's are all going to be running that. I'm actually starting some node assignments for these preliminary stations so we can keep those straight. But I'm making that a blocking task to finish that before I do anything, because we're going to be running off all of that and creating data from that. And I hope to have that out of my hair, hopefully in the next day or two. I've been working on it for now for 2 weeks. So learned a lot, and there's a lot of stuff there, and I want to push it out there and have people look at it, but that's what I've been concentrating on.
Thank you very much, John. That sounds good. And Eden, go ahead.
Let's see. So I have been spending lots of time on Python, and I've been working with Christina on the festival frequency measurement data. So we have some interesting things related to that. So we're still chugging along on that. And I mentioned it this morning, but I wrote a Python program that does some hopefully hassle elimination, as Christina referred to it, that validates the file formats from different, right now just the things being generated by FLDigi, but like it would be easy enough to use for like other CSV kind of files. So that might be useful to the project. It hopefully will be useful to me doing analysis. And I am also working on correlations, again, with the festival frequency measurement stuff. So that's pretty cool.
Thank you very much, Eden. That all sounds very good. And is there anyone else that I missed?
Yes, this is Bruce Kilo Golf 4 Hotel Lima Zulu. I just found out about the group a few weeks ago, joined on the Google site, and decided to come out tonight and see what's going on. Sort of learn a little more about the group, see how much I want to get involved. My background, I'm not a scientist. I have a bachelor's degree in computer science. I almost have a bachelor's in physics. Spent 20 years of my career developing laboratory instrumentation, software systems. Now I'm working in the defense industry, developing defense systems, mostly on the software side, but a little bit getting involved in a little bit of hardware every once in a while.
Well, it's very nice to meet you, Bruce. I'm glad you're able to join us today.
That sounds good. Sounds like you got some interesting stuff going on.
Yeah, we kind of have all sorts of things going on. As you can see, lots of people are working on lots of different things. So for figuring out where to jump in, probably the best thing to do is to listen for a little while and then see if there's something that interests you and see if you can help out with it. You know, ask questions.
Sounds great.
Wonderful.
All right, appreciate it.
You're welcome. Thank you for coming. Anyone else I didn't get? All right. Well, the floor is open for general discussion.
This is David. I wanted to ask a quick question. I noticed on the site that Dev was pointing us to, down in the lower right, there's a picture, if you click on it, of the antenna being used, which is crossed loops. I wondered if that's similar, the same to what Tom is showing behind him.
Is that for the
ionoson, the chirp
yes.
ionoson?
It's going to be very similar, I believe. It's not exactly the same because Tom came up with his own, but I'm pretty sure that it's going to be a similar sort of arrangement.
Yeah, do you guys see that down? It says dual polarization antenna, and you click on on it, and it looks almost identical.
Could somebody share their screen with that?
Yeah, hold on. You can share your screen, dude. Yeah, that looks very similar to what we want to do.
A lot smaller than I imagined it was going to be.
That's good though.
Yeah.
Yeah.
Yeah, that's a common form. I've seen them as basically crossed, you know, it looks like a pyramid sitting on the ground, but same kind of design.
Yeah.
Of course, I'll just mention I've had some experience with ionosondes. We just use the transmit antenna, the 100-foot delta loop as the receive as well. That's a little impractical, but you know, this is a much better, more easily deployable receive antenna.
Yeah, and I think we are really going to need that for the personal space weather station, something that is easily deployable and not too expensive and fairly robust. So I think this will fit the bill.
Yeah,
so
it's over on the far side here.
Okay, I was looking for that link. One of the things I was talking about with Tom is that I have purchased from DX Engineering some of their RF Pro 1B antennas, which is basically that, but only a single antenna. And it's not cross-polarized, but it's also very expensive. And so we're probably going to have to design our own and come up with a kit that is less expensive, or find some other option. Because yeah, you can see here it's $500 for one of them.
Yeah, DX Engineering is about 12 miles south of me, so I've been to their showroom and it's part of Summit Racing.
Yeah, I got to visit there on the way to Cleveland the last time when I went to the Hamsai Workshop you guys held.
The guy is real nice to talk to, and he's really built the business up. But yeah, their stuff can be pricey if you're not shopping around and being careful. Yeah. But he is an excellent source of the 6051 aluminum tubing.
Mm-hmm.
If you're doing any homebrew stuff, if you want the stuff to be telescoping or all the connectors or the clamps or you name it, he's got it. He's really grown it quite well for homebrew stuff.
Yeah. Well, Tim Duffy is their CEO, and he's been very friendly to us, and he's been very helpful.
Yeah, I'll mention they also have a good selection of fiberglass tubing.
Yeah.
So
the actual ham showroom is pretty small, but it's mainly online is really where you want to do your work.
Mm-hmm. Yeah. But
do you know any online sites for this a loop design that we can use?
Well, that's where I was talking to Tom McDermott, because he designed a loop a couple years ago for his Tapper DCC presentation, where he created a software-based ionosonde. And so you can find that here if you go to tapper.org and digital communication conference papers, which is under library. So library there. Then you go down to 2015, and you can find ionosonde. You Google ionosonde. Here is Tom's presentations. And so that's what Tom was just showing. He was just showing this, that he made homebrew. He said it was about $80.
Are there plans for that anywhere, Tom?
I'm working on a documentation package
Perfect.
for it.
Oh, great.
It would be nice to have two made. One's an existence proof, and two, we can average the performance and get a number.
Sure.
I would love to see those plans too. So sooner than later.
So would
I've
I.
got to boot up an old computer and find the schematic, and I've got a couple of design enhancements I want to throw into it to see if I can destroy the performance.
Yeah. Nice job, by the way. Very nice job.
Yeah, so I think that looks very promising.
The aluminum ones are better. I think the aluminum ones would stand up to a gale force wind. I don't know how the PEX tubing is going to do in a really huge windstorm.
It actually does pretty well.
It's flexible. It's not gonna.
Well, it more depends on how you have the box anchored than anything else.
Is there an optimal diameter for those, or does it make any difference really?
No, they're pretty broadband. The size of the loop determines its efficiency at low frequency, and it determines the upper frequency where the pattern changes from that of a small loop to that of a medium to large loop. A small loop has a figure-8 pattern with nulls in the plane of the loop, and a large loop has a pattern with a maximum going into and out of the loop. So the pattern rotates 90 degrees from low frequency to high frequency, and the size of the loop will determine the frequency range that those things occur over.
Is capture area a consideration?
A capture area is an easily misunderstood term. It's another way of basically saying gain of the antenna.
But yes, the area has a factor.
Capture area is the area through which the power density flows. And so it describes how much power one should expect to extract from the field based upon the power density. But if you have an antenna with a lot of gain, it extracts a lot more power. And so really capture area is just a different way to say gain.
Did you say this was amplified or not?
Yes, it's definitely amplified. Each loop has a bipolar differential amplifier. And so the amp has common mode rejection on the loop and then amplifies the difference. And it presents a medium impedance load to the loop, which is why the loop is broadband without tuning. If you try to put a small loop into a 50 ohm load, you have all kinds of Q and bandwidth and other issues.
So you've eliminated all the resonance issues with it then?
Yeah, it's non-resonant, so it just loads it tries to run the loop in its parallel rather than its series resonant mode.
Yeah, I presented, well, we did, between myself and Jim LaBelle, who I work for, we at the HamSCI conference, we talked about the antenna and preamp that we use that's also a loop and broadband differential amplifier. And the write-up on that is actually in the back of the ARRL book on receiving antennas that recently came out. Mike Trimpey, who's I call him our engineer emeritus, designed that system, and it's a good treatment whether you use his amplifier or not.
The amplifier I put in here was based upon availability of parts in the junk box and simplicity. I've not measured its common mode rejection ratio or anything like that. And I'm sure there are better amplifier designs out and something thrown together quickly. Can you provide a copy of that article or a link to it so we can look at the amp? We may want to, kind of merge a couple of design parts here.
Yeah, I've got a copy of it that I sent around to some people. I'll have to see if I can find it.
like my computer, it's about 14 directories deep somewhere. If you wait a minute, I can open this thing up and you can see what it looks like inside. It's pretty simple.
While we're waiting for Tom, this is Dave McGaw's presentation from the Hamsai Workshop, where that's your old design, right, David?
Yeah, that's actually a 2/3 of what we generally deploy. That's about 7 feet on a side there. But it's the same configuration that we have deployed all over the place. And this is the first one you were showing for AM broadcast. We don't need nearly that big an antenna. But we use the same preamp design. And I don't think, I know I sent some information on it during the HamSCI conference. Let me see what I can pull up here.
Let's see here. And Christina and Aiden, this looks like a good way to capture the Doppler shift information we're looking at with the HF system. So these like strip charts of Doppler observations. If you look at that.
Do you see, is there anything compared to some of the plots we've been doing? We had a similar kind of plot where we had multiple things in a strip, like a big stack of them all.
Yeah.
Was there anything about that you'd want to change?
Not that I can think of offhand. I think Tom is about ready to show us the insides of his.
One quick question. Does the color here map to the amplitude of the received signal? Is that what I'm seeing?
Yes, I believe so. The amplitude at a particular frequency. Here's.
Oh, because these are
actual. Yeah, these are actual like FFTs.
Oh, okay.
Yeah, what you're seeing is about 0.75 of a hertz wide spectral plots. And you're seeing the Doppler shift. And so the grayscale is amplitude.
Yeah, we can give that a shot. All right, thank you.
And here,
I'll mention that we have a student working on plotting these much better than these are. She's coming up with some very nice plots.
Would she be willing to maybe talk with us offline a little, and we could discuss means of visualization?
I don't see why not. I think we want to go through Jim LaBelle on that. It's his project.
I included a link to Dave's presentation here in the chat.
Yep. Actually, if you could bring up Jim LaBelle's presentation, Nathaniel, he had me defer to his for actual more on the preamp.
Okay. Let me see. You know, I don't know that I have. I'm not seeing his presentation on here. I don't know if I got a copy of it. I know we have it recorded, so I may have to ask him for a copy.
David, I'll send you and Aiden an email, and maybe we can take it from there. Figure out whom to send that to. Would that be all right?
Yeah, yeah, I can forward that on, and then we can get everyone in touch.
Awesome, thank you.
Are you about ready to show the internals there, Tom? Are you trying to? I think you're muted, Tom.
Thanks. It's hard to hold down the space bar with the third hand.
Yeah.
This is, so this is just a Home Depot plastic box. This is one loop, which is about 10 feet of RG8X. And this is the other loop of 10 feet. And then this is the bipolar preamp for one of the loops. This is the bipolar preamp for the other. And then each loop has a tunable 8 AM broadcast band trap in there. Is just mounted on a piece of aluminum. And then these are the brass PEX fittings. They have, you know, kind of like shark's teeth on the back, and then they're puckied up to try and make it waterproof. So it's a pretty simple amp. It needs a couple of emitter followers in each amplifier, so there's at least one improvement. The inductors, these are just hand wound inductors. This is the power feed inductor, comes in from the coax, does common mode rejection on the power feed. And then this is the differential single-ended transformer for the output. So just a simple diff amp with about 32 ohms of emitter resistance. And then not a real high amount of collector resistance. So anyway, just a pretty simple box. And it's just all flea clips and leaded parts. So obviously, if you turn that into a real circuit board, you could make it about 1/10 the size that it is.
Thanks a lot.
Yeah, if you like, Nathaniel, I at least have the our preamp schematic if people would like to take a look at it.
Sure, you're welcome to share that.
Yeah, so this is the preamp that we use. That's use a couple integrated circuits. This is our small loop that we use. It's actually half size that we've used for high frequencies. We did some work at looking at higher order HF roars, which are in the 4.5 to 9 megahertz range. There's another version of this preamp that works lower down. But for the differential part of it, we use a transformer. Mini circuits and Coilcraft makes some very nice versions that we use there. And then these are determined, each of these amps has has feedback around it, so it's determined gain. And then it has a resistor feedback that sets the load resistance. And these are generally set to something on the order of 30 ohms. Load on the loop, which with the inductance and the resistance, that's your basic broadbanding of the loop. So that, higher frequency, you get more pickup, but you also have higher inductance. So the two balance each other out through a range that can be determined. And these are, of course, all remote powered through the coax. And we've done both single channel and dual channels of these. We do a lot of circular polarization work, determining whether things are left hand or right hand. So we'll have two of these feeding either through two coax, or we'll do the phasing and out at the antenna and send left hand polarized, right hand polarized, switching back and forth, and we determine which one is which. So I do have a document that I've sent around to other people. I'm just not finding it right now, but if anyone's interested, I can forward it on once I find the full document. It includes this, plus the Mike Trimpe's treatment of figuring out the response of the loop system.
Thank you very much, David. Any other questions?
David, thank you for sharing the schematic.
Yep, no problem.
I'll get a package out here over the weekend. That's what I always say.
Well, I think we're coming close to the top of our hour here. So I do want to talk about one more thing before we go. And that's the CDAR meeting. So CDAR is an NSF program, National Science Foundation program, called the Coupling of Energetics and Dynamics of Atmospheric Regions. So this is a workshop that all of the universities and people who are funded to study the ionosphere go to every summer. And of course, this year it's going to be virtual. So, and it is also going to be no cost. So they're still trying to figure out exactly what the virtual CDAR is going to be like, because they haven't done this before. And it's a much bigger meeting than, say, the Hamsai Workshop. It's, probably around 300 to 500 people, and it generally takes about a week. So they're still trying to figure some things out, but you're certainly welcome to go look at this webpage, and I can put that link in the chat also. And kind of see what's happening. I have been invited to give a highlight presentation about the personal space weather station to this group. So I'll be submitting an overview video to this workshop, and I'll probably be trying to figure out a couple other ways that I can participate. I'm not sure that I would necessarily recommend that people here generally give a presentation at this workshop, but I think this is a really good opportunity to kind of see what's going on in the CDAR community and how and see what some of this research looks like. So if you are interested in doing this, you can sign up and you can take a look at the the different presentations and what we're doing. And ultimately, the observations for the personal space weather station, they're going to support this community. So it's really the essentially the NSF CDAR program that's providing the funding for the personal space weather station project. Well, I think that's about it for today. Any other things before we sign off for the day? No?
I will say that I just found the design article if you want me to show it really quickly.
Sure, go right ahead.
There, this is what we have for design equations. And let's see if I can, it doesn't like, there we go.
So this is in the
There.
ARRL receive antenna book?
It's in the, yeah, the ARRL receiving antennas book. Forget, Nichols is the author. But this is Mike Trimpe's work. It's a document that he sent in and got published in this book. And the odd thing is I have not been able to find an original of this document. So I just took it out of the book, but it's Mike's standard design document. We've got copies at the lab, but they're all marked up. I haven't found a PDF of the original other than this, but he goes through and we also, show what the calculations for the antennas sensitivity is, and then the we run a calibration input to it, and he gives the calculations on all of that. So, and then here you can recognize the amplifier that I just showed you, where 2 gain stages plus a feedback resistor and a transformer. And it's been a very effective amplifier for us. As I say, we've used it up to like 10, 15 megahertz, but the design can be tailored to whatever you might want to use. We've done it down at AM. We've actually have a number of systems that run in that band, but we'll deploy them out in the field, like in Antarctica and Greenland, not for AM broadcast, but for AKR, auroral kilometric radiation, which is in that same range, and normally gets masked by the AM broadcast stations. That's an interesting phenomenon in that it was thought that it all propagates out and not down to the ground. We've discovered that's not quite true. Oh, and then he gives a very nice list. He's good at cataloging things like low noise amplifiers. So if you want to pick an amplifier, he's got a good list here. We're using an amplifier which is unfortunately obsolete now, but is in this same range as these FETs here, about 1 nanovolt per root hertz.
Yeah, I spent an entire career chasing after those kinds of specs. So yeah, that was all familiar.
Yeah. Now let's see. One of my favorites, of course, is the 797. I actually worked for Analog Devices. And the guy who helped design that, trying to see where the one is that we use. It's the LT5135 that's my thing here is not helping me. It's one of the really low noise ones. INA 163 is another good one. Anyway, I'm not catching it now, but it's on there. Oh, here it is. The EL 5135, 1.5 nanovolts per root hertz, but very good bandwidth.
Yeah. I recognize the 6001 because that's used for picoammeters because the input
Right.
current is in femtoamps.
Yes. So I guess I'll pop that off.
Nathaniel, you are muted.
Thanks. I was gonna say thank you, David. I really appreciate you sharing that. And I think it sounds like people are working on lots of interesting projects. And I think this direction for trying to get this antenna design figured out, I think this is a very good direction. So thank you very much for everyone's conversation today. So it is 4 o'clock. I think I will say 73 to everyone. And we will meet again in 2 weeks.
Thank you so much.
73,
Thank you.
everybody.
Take care, everybody.
Everyone.
Take care.
Take care.
73.
Leave it up for a second, Nathaniel. I'm still putting something in the chat.
Sure, no problem. I'll hang
Good
around
seeing
for.
And Nathaniel, we're up Radio Club 30?
Yeah, 5:30. You have the link?
Yes.
Great.
Good.
Hopefully we'll get people to show up.
You want us to have prepared?
What's that?
Anything special you want us to have prepared?
No, I just want you to talk about what it's like being a college radio club and why you do it and how you have fun and what students get from it and pretty much all the stuff you always do anyway.
Communication, like to talk. It's okay.
Yes, yes. So yeah, as I said, hopefully we'll have students show up. I know Jonathan Rizzo, it's his birthday today. He said he has to show up a little late because he has work, but hopefully we'll get a couple students. All right. So I guess Jerry, did you get everything you wanted put into the chat?
Not quite. I'm waiting for something to download from from a .mil site, and it seems to be taking forever.
Oh, okay.
I wanna
Simon,
see
the
it'll
Simon
just take me-
Shepherd paper.
Yeah, this thing is either huge or my connectivity has gone down to kilobits per second.
Something from Simon? This one of Simon Shepherd's papers you're looking
Yeah,
at?
the polarization of auroral radio emissions.
Oh.
Yeah, it's Simon Shepherd, Jim LaBelle, and Mike Trimpe.
Right. That's his thesis?
It's a GRL from 1997.
Right. You know, Simon's still with us, of course. He works on Super Darn.
Yeah, I spent what 2-3 weeks with him on Adak Island.
Ah.
Yeah, building a radar out there.
Right.
Yeah.
I almost ended up at ADAC once upon a time, but thought better of the Air Force for a while.
Adak is a special place.
Especially when you speak Russian.
Do you speak Russian?
I так, немного.
On the trip back from ADAC, after building the Super Darn radar, I was talking to someone at an airport or something like that, and I was just talking about my trip a little bit, and they said to me, they're like, "Did you bring a rock back from ADAC?" And I did, for whatever reason, and I was like, "Yeah, I did actually," and I said, "Why?" And they said, "Well, when we were in the Navy, everyone after they'd leave ADAC would take a piece of the island with them in hopes that one day there would be no ADAC left."
Well,
okay, I'm going to post this and then I'll be done. And I have not read it yet, so
So hopefully it's good.
Yep. Well, it does show we're doing much the same work now that we did back then.
Yeah.
Well, you either study history or repeat it.
Or are it.
And here's a link to various Ionoson links we found.
Yep. Yeah, that's actually at that time is when I was actually working with Millette Morgan on Ionoson.
Huh.
I still think we need to put together a micro ionosonde as part of this project.
Well, we're starting with, you know, a lot of people are working on that. Certainly, as part of this project, we're doing the receive Ionoson signals of opportunity.
Right.
And there's a lot of reasons for that. But a lot of people are also actually interested in building an actual Ionoson. So Bob Melville is actually very interested in doing that.
Mhm.
And he keeps...
Well, the one who has done that is Yuha.
Yeah.
He's figured out how to use milliwatts to sound the ionosphere.
Let's stop the recording.